Today we're doing section 6.5, and this is the product and quotients of polar forms. So to find the product of two complex numbers, we take these two z values, so z1 times z2, you multiply the two radii together, and then you simply add your angles together. So theta 1 plus theta 2, and then again plus I sine. Let's see if I can fit this all in here. I sine of theta 1 plus theta 2. So essentially you just multiply your radii together and you add your angles together. So for our first example, our two complex values, so z1 is equal to 4 cosine of 50 degrees plus I sine of 50 degrees. And our second value, z2, is equal to 7 cosine of 100 plus I sine of 100 degrees. So obviously we could do this in radians or degrees, the same rules apply. So to find the product, I have z1 times z2. And the formula says that you multiply your radii together, so 4 times 7 will give us 28. And then you add your angles together, so I have cosine of 150 degrees plus I sine of 150 degrees. Now obviously I could say stop here in complex form or polar form, or I could say convert this to rectangular form, which is what we practiced yesterday. So if I asked it for a rectangular form, you would use the coordinates that correspond and go one step farther. But we'll leave like this for now. For the next one, we are finding the quotient, and the quotient formula is very similar, and you could probably figure it out. So if I'm dividing these two values, I would divide my two radii, and for my angles, we are subtracting them now. So theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. So if you need to pause that, go ahead and pause it so you can copy it down for our example. Z1 is equal to 12 cosine of a 3 pi over 4. I can't get this pi right. Plus I sine of 3 pi over 4. So that's our one coordinate. And our second coordinate, z2, is equal to 4 cosine of pi over 4 plus I sine of a pi over 4. And the directions say to find the quotient. So if we're finding the quotient, that means we're dividing these two values. So z1 over z2. And it says we divide our radii, so 12 divided by 4 gives us 3. And then we subtract our angles. So when I subtract these angles, 3 pi over 4 minus pi over 4, luckily I already have a common denominator, so that's a 2 pi over 4, but that can reduce. So let me just kind of write it above. 3 pi over 4 minus 1 pi over 4 is going to give us a 2 pi over 4. But we can reduce that and just say pi over 2. So then this one's also going to be pi over 2. And let's actually practice going into rectangular form because I think it's just good practice. So we're not forgetting that. So off to the side, we would write down our coordinate for pi over 2. So I know pi over 2 goes straight up, so that coordinate is 0, 1. And then we're going to go back over here. And I have 3. Cosine pi over 2 would be 0 plus I times sine of pi over 2 is 1. So I have 0 plus I. And then I distribute my 3 in, so I'd get 0 plus 3i. So this is the rectangular form of this equation up here. So that's all for today. We'll pick up with this tomorrow.